My name's Owen Garrett. I work on the product team at NGINX, so I look after roadmaps and future capabilities. And with me, coming up later on, will be my colleague Faisal from the engineering team. Here's Faisal. We do have a number of engineers from our service mesh team in the room. As I look around and from the NGINX team as a whole, Faisal will be giving a demo. We're very happy to take any questions, any technical questions. They will probably go well beyond me, so Faisal or the other engineers, I'm sure will be delighted to help. So guys, don't hesitate to speak up and help the rest of the audience if they've got questions. As Rick explained, operating a distributed application is very, very hard. And from a service mesh perspective, the reason that it's hard is that you're replacing something that is reliable, is safe, has no latency, very, very rarely ever fails. That's a function call within your application. You're taking your application, you're breaking it into individual distributed components. And those fast function calls are getting replaced by network calls. And the network call, an API call, is an abstraction to the function call. From the app's perspective, it probably looks no different. It just makes a call, but underneath there's an abstraction. We're using the network. The network has latency, it's slow, it's unreliable, it can fail sometimes. The remote component can fail. So not just the network fails, but maybe the remote component you're trying to access isn't even there. You can get errors, there are security issues that can be snooped. So all of these things make it much harder to take a monolithic application, convert it to a microservice application, and then operate it in production. Ideally, you want to be able to take your microservice application and you want to be able to see the topology. Here's just an example one that I made up. So don't pay too much attention to the details. You've got a bunch of components, you have interconnects, you have a nice logical topology in your head for what your microservice application looks like. But when you deploy it in production, all of that nice topology is lost. Kubernetes gives you a flat network. You have a bunch of containers that all look the same but are slightly different. And you lose the topology and you lose a lot of capabilities that you would need in order to operate the application successfully. You want the ability to secure the application because now all of the sensitive function calls are going across what's potentially an untrusted network. You desperately need the capability of instrumenting the application, understanding who is talking to what are the latencies, what are the error rates, what are the locations, and along with instrumentation, you need the ability to trace those calls. Things that are relatively easy to do when the application sits in one big monolith become very, very difficult to do when it's distributed across multiple nodes, potentially even in different physical locations. And finally, as you operate this thing in production, you need the ability to control the traffic within the application so that you can operate workflows such as a canary deployment, where you wish to upgrade an individual component, or a blue-green where you want to migrate traffic from one place to another, or a circuit breaker so that you can put in place a break, a standard error page should a component fail, or a rate limit if a component is somehow vulnerable to spikes of traffic. So all of these things are capabilities that you need to add when you go on this journey from a monolith to a microservice. Service mesh sits somewhere along the end of that journey. But before we get to service mesh, I'd like to talk to you about some of the precursors, some of the ways that people have used NGINX and other proxies to address these problems and build things that are like a service mesh, although not a full-fat service mesh. And this is useful for a couple of reasons. Maybe it gives you some pointers on ways to solve the problem that you might not have considered. Pointers that are proven production solutions. And also, by understanding these precursors, you also get a better appreciation of what it is a service mesh really does, what are the unique additional capabilities it has, and what benefits does that bring. And that will help you as you think through, do I take on the complexity of various different stages of solutions, and what are the benefits at each of those stages? Jumping straight in, Rick talked about in his maturity journey, level 2, some of the solutions that are built with NGINX. A very, very common pattern that we see is that people build NGINX into individual pods. This might seem like something slightly esoteric, but if you think of an application server such as PHP FPM, very, very common way of running PHP code, you need to put an HTTP front end in front of PHP because FPM just talks fast CGI. So anytime you deploy PHP within a microservice environment, you probably put something like NGINX in front to give it an HTTP interface. If you deploy an application where you've got limited control over what that application does, so maybe it's a big app running on WebLogic and you need to implement an authentication measure or a rate limit or something that WebLogic itself doesn't do, or you can't modify the code. WebLogic is sitting in a container, you put NGINX in front of it. So WebLogic in a pod, you put an NGINX container in that pod, and you use NGINX to implement those capabilities. So this approach is very, very common, to take either an existing app that doesn't speak HTTP particularly well, or an app that you can't modify and you need to add capabilities to. You extend your pod by injecting an NGINX proxy. It's simple to deploy. It's often done by the application team themselves. When they master and deploy the pod, the infrastructure team never needs to know. The entry point for the pod is now NGINX, and that gives you a point where you can control traffic coming in to the application. You can implement things like SSL termination. Maybe you can do that better within NGINX. You can standardize things like authentication. This still relies on the load balancing, the Kubernetes capabilities, so something like kubeproxy to load balance. But simple for adding features like tracing, web app firewall. You can use the tracing capabilities you get with NGINX, for example, to implement open tracing for your app. This falls short in one important way. With a service mesh, the goal of a service mesh is to be able to control both ends of a network connection. By putting a per pod proxy in each pod, you can control the end of the connection, the ingress where it enters the destination pod, but it doesn't give you any control over the egress, how the traffic is initiated. And this can be a challenge. Sure. This can be a challenge if you want to do, for example, mutual TLS, because you want to secure the connection end to end. You need, in that case, to rely on the application to initiate the SSL connection and to have the right SSL credentials and do the right certificate checking to play its part in the MTLS network. It can be an issue if you're trying to generate metrics or traces and you want to generate those from the client side. So you want to know what is the client seeing about the transaction. With this approach, you only get those from the server side, so you don't get to see the influence that network latency or network jitter or even dropped connections would have on this. It also means that you don't get full control over the load balancing, which is used within the microservice network. So the application, the left-hand side, decides where it sends traffic to, and you have to rely on the built-in capabilities of something like Kubernetes to perform the load balancing for you. You don't get the traffic-based load balancing that you get with a proxy, with a full proxy on the left-hand side that understands the topology of the app. A number of our users have addressed this problem, have taken control of both the egress and the ingress traffic, still using NGINX as a sidecar proxy. We call it, or I refer to it as a simple mesh. This is where it's simple mesh, simple because it's significantly simpler than a service mesh, but nevertheless is fairly complex to build. And this, as we talk through it, I hope will illustrate what are the additive capabilities that a full-fat service mesh puts on top of an approach like this. We industrialize and support this using our Fabric model. There are several customers who are running with solutions like this in production. I've talked with customers who have built solutions like this themselves. And in this case, they take control of both the ingress and the egress traffic by putting an NGINX container within the pod, routing traffic, so the egress traffic from the application is routed to the NGINX container, and then NGINX forwards it out, putting in place a network policy to enforce that that takes place. And then they need to generate the NGINX configuration. And this is where it starts to get difficult. If you know which external or remote services your containers, your pod is going to talk to. Then you can generate the NGINX configuration, just correspond to that. You can put in place a virtual server or a rule for each of those services. If you know the policies that you want, if you know the capabilities you need, you embed that into your NGINX configuration. But should you need to change those policies, should you need to add more, change the topology of the application, you then have to find a way of regenerating and redeploying the NGINX configuration. And that, when you're doing it in an ad hoc build and master way, is extremely difficult to do. If you need to redistribute your SSL certificates, your authentication credentials, you need to update any policies. Once the configuration for NGINX is built in this fashion, it's very, very difficult to change. And so this is the final step before you were to move towards a full service mesh. Limitations of this step: you need to understand the topology of the application. You need to be able to build the NGINX configuration for the routing rules when you deploy the application, and it's extremely difficult to change that configuration once those components are deployed in production. A service mesh attempts to solve these problems. It's appropriate when you don't know the topology of the application, but you're looking for some sort of off-the-shelf solution. The complexity, as Rick described in the previous session, is still fairly high. What a service mesh does that is different from the previous solutions is it adds a dedicated control plane. It still has a proxy within each individual pod as a separate container, running NGINX or Envoy or Linkerd or something else. But the configuration of that proxy is fluid. Anytime the application as a whole changes, so a service scales, a new service is deployed, an SSL certificates are updated, authentication tokens are rotated, anytime anything like that changes, the job of the control plane is to talk to every single proxy and push out the new configuration. Or in some implementations, it's more of a pull basis where the proxy has a permanent connection back to the control plane in an SDN-like fashion and pulls configuration from the control plane on the fly. This is the pattern that you see implemented in things like Istio and Linkerd and other emerging service meshes. What this allows you to do is to build a general purpose service mesh that learns the topology of the application, but with it comes the cost of having a control plane that is constantly communicating with every single proxy and managing and updating the configuration of those proxies. That's why we say in many cases it's not fully mature. The control plane can be a point of failure. There can be communication issues between the control plane and individual proxies. That means the service mesh gets out of sync. The particular implementations of service meshes rely on many, many layers of things like IP tables to route traffic. So these are all things which are maturing over time, but as Rick said, right now need the equivalent of a Formula One pit crew in order to massage and monitor and keep running. So that said, as part of the obvious evolution of our approaches, we are building a service mesh implementation. We're building it because it aligns very well with the other capabilities that we're building through Controller with NGINX. A modern application is hybrid. Microservice, it has legacy components, it uses web and API interfaces, multiple technology stacks, and the three things, the core things that a modern application needs to support it are load balancing and application delivery capability, API gateway, and for internal traffic, some sort of service mesh implementation. So the three capabilities come very, very well together as part of the NGINX application platform. And in our architecture, we're tracking the table stakes initial features, and you'll see some of these running: mutual TLS, the instrumentation and tracing, and the traffic control capabilities. The core principles behind our design: first of all, we want to take a hybrid first approach. We're not building a service mesh which is exclusively limited to applications, containers, pods running on Kubernetes. We're building a service mesh that from the first public release will support hybrid environments where some components are in Kubernetes and some are outside. If you think of the strangler architecture that Rick described in the previous presentation, you want your service mesh to extend beyond Kubernetes and reach out to the other dependent components that you have control of. NGINX and NGINX Plus are as lightweight and as performant as you can get. You can fit NGINX on a floppy disk, as we've demonstrated many times. It's a perfect lightweight sidecar proxy. Architectural simplicity. The goal is to build something which is separate from what you have to make it easy to deploy, easy to remove, and we do not wish to reinvent the wheel at any point where that might be necessary. We want to rely on leveraging the tools and the projects and the processes that you will already have within your Kubernetes environment. We won't be building a dedicated monitoring interface, a dedicated tracing interface, dedicated tooling where existing tooling exists. So our goal is to create something which is as sympathetic and as friendly as possible to the ecosystem. Very quickly, before we get through to the demo, if you were to start with a hybrid application, you have here 6 services split across a range of different deployment environments, communicating to each other. Our architecture starts by embedding proxies within each of those services. On Kubernetes, as a sidecar proxy, in other environments deployed in other ways in order to capture and manage the traffic. We will be building a separate control plane that is driven through CLI or an API. It understands the topology, or rather learns the topology of the application. It understands the policies that you have and uses that information to push out and manage the configuration running on the NGINX-based sidecars. We have a working implementation, which you'll see shortly, of mutual TLS, talking SPIFFE to the Spire framework. We have working implementations of Prometheus, talking to Grafana, of open tracing, talking to tools like Jaeger or Zipkin. When I say these are working, they're working in the lab. The demo that you see is an engineering preview. We are still some way away from a first public release, and I won't be drawn on a date at this point. But most of the work has gone into the data plane. And a lot of this will trickle through and benefit the community as a whole. Our data plane is implemented using NGINX. We use the open source open tracing module. We have adopted that by putting it into our own repository for NGINX Plus, and we will work with the open tracing team to ensure the ongoing support and maintainability and workability of the open tracing module with NGINX open source. We have built a Prometheus module. Aidan built that, implemented in JavaScript, running directly in NGINX Plus, which we will open source. And in time, I'll talk about some of the changes coming with NGINX tomorrow that will also be relevant to NGINX open source itself. We've implemented SPIFFE support. Faisal was the lead architect for that. It's not complete yet, but the intention is to open source that. The core proxy is built on NGINX Plus, and it uses some fairly sophisticated configuration within NGINX to support fully hitless reloads. One of the challenges of NGINX historically has been that any configuration changes mean rewriting configuration and reloading NGINX. You can do that at a fairly low cost, but there is still a hit. There's a lot of work gone into integrating with NGINX Plus so that we can make those changes on the fly. We can add services, remove services, change policies, and as far as possible, we can do that without any hit requiring a reload of configuration. So without any more delay, I'd like to invite Faisal up. And Faisal, if you could run through with us some of the capabilities we've built already and how they function.
Sure. Let me switch over. Okay.
So you might need to drop out PowerPoint so we'll do a proper share. There we go.
Okay, cool.
There we are. Okay. So you have a Kubernetes environment.
That's correct.
Set up. What does it take to enable that to run the service mesh?
Sure. So the primary way that we interact with our service mesh is through our CLI. And so if you... wrong window. There it is. Go service mesh CLI -- help. And are you guys able to see this? Is it big enough? Okay, good. We have a lot of help there. So we have a lot of different commands. We have a top command to see the top services. We have an inject command to do injection of sidecar containers into your pod. We also support auto injection, which we'll show in just a few minutes. But the main way that you deploy the mesh is our deploy command. So you'd go service mesh CLI deploy. And of course, we have the embedded help there, and we have a lot of different options of how to deploy it, and all these have default values. So when we deploy it, what I usually do is, of course, do deploy, and I do /m, and for that list there, that's what also deploys the Spire server and Spire agent, which gives us MTLS. So I already deployed it earlier, so I'm not going to deploy it now because it does take up to 30 seconds to a minute to download all the necessary containers. But if I go, kubectl get pods a, and once that comes up, we'll see that we have a number of different pods there. So we have this, the kube system stuff that's typical to any deployment, but we have the stuff that we have deployed under the NGINX proxy API namespace, which includes the Prometheus and Grafana, which Owen mentioned, Zipkin for open tracing, and then proxy API there is our actual control plane, which does all the control plane functionality of programming the NGINX sidecars. We also create the Spire namespace, and that what contains the Spire server, which is our CA, and that's what issues certificates to each of the workloads in the service mesh. And there's a Spire agent per node, so I have 3 nodes in my Kubernetes deployment here in GKE. And so each node gets a Spire agent, and what NGINX actually talks to is that Spire agent through a Unix socket. So when NGINX comes up in the sidecar environment, it talks to the Spire agent through a Unix socket, and then pulls the certificate up through that way. And the Spire server will push the certificate down to the agent. So the certificate starts from the server, gets pushed down to the agent, and then gets pushed to NGINX.
Cool. So we've seen the basics. Faisal, could you deploy an application and show what changes in the app as we enable it with the service mesh?
Yeah, absolutely. So to do that, I'm going to use the good old Bookinfo application. So if any of you guys are familiar with Istio, Bookinfo is a nice sample microservices application that that team wrote. And we use it extensively. I call it the gold standard. So any tests or changes we make, it has to work with Bookinfo. So I'm going to go ahead and deploy the Bookinfo application. And so you just do kubectl apply, just like you normally would. And one thing that we'll notice when, first off, that it's actually downloading all the stuff, but that each pod within the Bookinfo application, Bookinfo has, it looks like 6 separate pods, 6 separate services. And so each pod has 2 containers in it. And so one container is going to be the actual service itself, the detail service, the product page service, the different services within the Bookinfo application. And the other one is going to be the NGINX sidecar. So we can look a little bit more detail into one of them. So we'll look at the details service here. And I think that should work. Yeah, there you go. And so just scrolling up, we'll see, you can see that there's 3 containers here. So we have, first off, an init container. And what the init container does is it goes and programs the IP tables rules to direct all traffic to the NGINX sidecar. It's the same thing that Istio and Linkerd do within their service mesh deployments. And then once it programs those IP tables rules, the init container goes away. The next container is the actual service here. That's the Bookinfo detail service. And when we show what the actual Bookinfo does, we'll see what that guy does. And then the third thing is the NGINX sidecar, and that's what we call the proxy agent, and that's down here. And so that contains the actual NGINX sidecar that the IP tables is redirecting traffic to. So now I can, show so I'm just going to set up a few port forwarding rules, and then we'll see the actual Bookinfo at work. There it is. Okay. So now I'm going to go and over to my web browser and load up the Bookinfo application. So if you've not seen that before, that's the Bookinfo application written by the Istio team. We can click in normal user, and this is where it does the actual microservices functionality, which is this page is built from multiple different services. There's a product page, which is the front end, the detail service, which provides a panel on the left side, and then a ratings and review service, which provides the detail on the right side, and we can refresh it. And we'll see that the color of the stars changes, which is built into the book info application because there's 3 different versions of one version with no stars.
Okay,
so that's the book info application.
So far this looks just like book info in any other guise, but we're running on the service mesh. Can we use the CLI tool to see the traffic that's going through the application?
Sure, we can definitely use the CLI to do that. And let me go back to the CLI. And so, we just go to that same CLI, service mesh CLI, and go to help. And we have a top command that's there. And so we can go top, and we're going to go ahead and just sort it. And we can see here that we got a number of requests to the different services there. And for some reason, it seems like one of the review service has not got any traffic, but it's also, does take a second or two to update it. We can see the top talkers there, the success rate for each of the services pulled from the sidecar.
So this gives us a basic overview of what's happening.
Correct.
But we mentioned that we're doing some additional instrumentation and plugging into some of the ecosystem tools.
Yeah.
So what else can we use to visualize this data from the service mesh?
So I'll show now our built-in integration with Grafana. So if you remember earlier, I showed that we deploy a number of different pods as we deploy our mesh, and Grafana is one of them, along with Prometheus. So this is the dashboard that I built. It's pretty much the same as the standard dashboard, but I just added a few things. But we can see, this cliff here where, this is where I started the demo. So we went from no traffic to, a handful of requests coming in. We can see the success rate for each of these pods. So I can go over here and I can see that the pods that have received traffic, they're all showing 100% success rate at this point. We can even see the SSL handshake. So we said earlier that we do MTLS, and I deploy the service mesh with MTLS. And so behind the scenes, when all the services are talking to one another, they're all doing it in an encrypted fashion using TLS encryption. And so we can see that each of these services is doing SSL handshakes as they talk to one another.
Cool, so we can see what's happening in our application, but one of the other use cases of a service mesh is that you can then control the traffic to do things like a blue-green update. So could we try updating one of the components in the app and see what happens?
Yeah, definitely. So let's imagine a typical scenario as an operator. The developer has come by and he says he has a new version of the application, just some few under the hood changes, nothing that should affect anything. So let's just go ahead and deploy it. So I'm going to go ahead back to my environment here. I'm going to deploy a new version of the book info example. Actually, before I do that, first thing I'm going to show is the traffic splitting capability that we have. And so I'm going to show our traffic split rating. So what we're going to do is a canary deployment, right? Because we want to be cautious. There's a new version of the application. It should work okay, but just in case, we're going to do some traffic splitting. So I have created a traffic split here. This uses the standard SMI spec traffic splitting. And what you do is you define the different services that you have, and just a hint of what's coming forward. One of them is not going to work. So we have 2 services here. Let's say the previous version, ratings v1, and the new version, ratings v faulty, and we can define a weight, and the weight determines how much traffic gets sent to each of them. So let's, if I make it, for this example, I'm going to make them, even, so they're both split 50-50. But, if you're doing a canary deployment, you'd probably want to do something more like a 10-to-1 split, so that the older service gets 10 times as much traffic as the newer service. But just for the demo here, we're going to make it even because it makes it easier to demonstrate the functionality. So now I'm going to apply the new version of the book info application with the faulty service. And then now if I go kubectl get pods, we'll see here that there's a new v-faulty version of the rating service along with the standard v1 version of the rating service. And I'm going to apply our traffic split policy using the same functionality. So I just go traffic split file kubectl apply -f, and I can also just go kubectl get traffic script, and I can even go traffic script YAML, and we can see the output of it and some more details. You can also do describe and other things with the traffic split.
So that traffic split policy has now gone and updated the NGINX configuration.
That is correct.
So it's now sharing traffic between our 2 different services.
Correct, depending on the weights that we provided. And so now I can go back over to my Bookstore application, and we can just test it out by doing a few reloads. And let's see, hopefully, everything should work, but we're going to keep refreshing, and now we've run into a problem. The rating service is currently unavailable. So what's going on here? Let's go look at Grafana. Will that tell us anything? And we're going to go over here to our pod success rate, and we'll see here that might be a little small to see, but you can see that the faulty there has a 0% success rate, so that we know that now something is wrong with this service. So what can we do? So what we can do is, and then go back now to our traffic splits. I'm just going to go ahead and edit that same traffic split file and saying, hey, okay, now I want to shut off that faulty service. So now instead of giving it a weight of 1, I'm going to go ahead and give it a weight of 0 and then apply it again. There you go. And now I go back to my service here, and let's try refreshing it a few times. Let's see if that error has gone away. The way the service works, it errors, and the way it's set up, it should error 1 in every 4 or so requests. So we just do a few refreshes, and we see, okay, everything's okay now. We put that faulty service out of commission, and then we can go back and go ahead and fix it with the developer that was in charge.
Brilliant. Thank you very much, Faisal.
Thank you.
Thank you. Okay, so as we wrap, Rick explained that there is a balance to be struck between the different technologies that you use. A simple application, stage 1 of his journey, requires relatively little capabilities in order to operate successfully. As the application grows in complexity, the cost operating that application using native Kubernetes capabilities and some of the other services we talked about, NGINX per pod proxies, per service proxies, NGINX simple mesh, those get more and more expensive and complex as the application gets more complex. Service meshes are a new innovation, a new entrant that try and level that off. There is currently a high bar to get started with a service mesh, but it introduces a tipping point. Once your application gets beyond a certain degree of complexity, at that point, current service meshes promise to provide a lower cost of operations. And over time, as the service mesh gets easier and easier to operate because it gets more and more mature, that's going to come down. Our recommendation to you is look to solve today's problem today. Understand what the problem is you're trying to solve. Is it a problem of security because you're on an untrusted network? Is it visualization or tracing that you can't get from the application itself? Are you having trouble with certain workflows and you can't find the tooling to do that? And find the solution that deploys the minimum technology necessary to solve that problem. Maybe it is straightforward Kubernetes. Maybe there's some customizations that you can use using the NGINX suite of tools. Or maybe you're at the point where you need a full fat service mesh. There's a lot happening and changing in the service mesh marketplace. What we showed you is a very early implementation of the first stage of our service mesh implementation. It's something which we aim to have being fully supported, lightweight, high performant, but there's still some time before that comes to market. I'll bring things to a close now. I hope this has been useful in both sharing with you some of the ways that people solve service mesh-like problems already using NGINX and giving you hints to some of the things that are coming in the future. So thank you again to Faisal. Thank you to you all for your attention this afternoon.